Welcome back to my channel. So after the implicit differentiation, now we are going to the differentiation of trigonometric functions. So the differentiation of trigonometric function actually is, the derivation is not needed in the STPM syllabus. However, we can try to derive it, and if you are not interested in the derivation part, you can just memorize and skip this part and skip to the summary parts. So yeah, so here we go. So we know that y, and this one is dy dx. So the first thing we're going to learn is sin x. When we differentiate sin x, we get cos x. Of course, you can just memorize this, but I will try to derive in these videos. So you can see y differentiate sin x equals to cos x. So now we let fx equals to sin x. So by using first principle of differentiation, we know that f prime x is equivalent to limit delta x approaches zeros. Here is fx plus delta x minus fx over del x. So now we replace the fx with the sin x, we get this sin x plus delta x minus sin x over delta x. Alright, so how are we going to deal with this? So we apply the trigonometric rules. I must say that this one we learned in the SEM 1. I hope you all still remember sin x plus y equals to sin x cos y plus cos x sin y. Whereas sin x minus y is equivalent to sin x cos y minus cos x sin y. Yeah, right? So this one we let equation 1, this one let equation 2. So how are we going to deal with this? We know here is minus, right? So now we're doing here, 1 minus 2. We will get sin x plus y minus sin x minus y is equivalent to 2 cos x sin y, right? So from this equation we have x plus y and we have x minus y. So how are we going to deal with this? We let x plus y equals to anything alpha, so and let x minus y equals to beta. So now let this one equals to 3, that is equation 4. So 3 plus 4, we will get 2x equals to alpha plus beta. But if we simplify, x equals to alpha plus beta over 2. Now if 3 minus 4, we will get 2y equals to alpha minus beta, where y equals to alpha minus beta over 2. So from here, we can substitute inside the equation here. So now you can see sin x plus y is alpha, so I replace with alpha. Then sin x minus y is beta, so I substitute with beta. 2 cos x sin y, so I substitute the corresponding equation, alpha plus beta over 2, and here is sin alpha minus beta over 2. So what the relation between this equation and this equation we find? So what's the relation between, we want to find the differentiation of sin x? So let's see. So now we have the f prime x equals to limit where the delta x approaches zeros, and this is sin x plus delta x minus sin x over delta x. So how we're going to do is, we can see actually here we have sin alpha minus sin beta, where alpha is a term, beta is a term, x plus delta x is a term, x is a term. So now we can make analogy. So we know that alpha is actually equals to x plus delta x, where beta is equivalent to x, right? It's negative, here is negative, so it's both the same thing. So by implied analogy, we can equate the both sides. So we know that f prime x will equivalent to limit delta x approaches 0. Then we move, it will become 2 cos alpha plus beta, means that x plus delta x plus with x over 2 sine alpha minus beta. Alpha is x plus delta x minus beta. Beta is x. So here is like that over 2. Here is delta x. Alright. So now we simplify it. We will get 2 cos x plus x. We know that x plus x is equivalent to 2x. 2x over 2 is equivalent to x. So it will become x plus delta x over 2. Here is sine. X and x cancel out. We will get delta x over 2 over delta x. So now to make it beautiful, I can say to make it beautiful, we put the 2 down here, and it will become cos x plus delta x over 2 sine delta x over 2 over del x over 2. Right, so we just move the 2 downwards. So now we know that when delta is in radian, when our delta is very small, means that delta is more than 5 degrees, I can say that it's very near. You can try your calculator. You can try calculating that the sine theta is almost approaches theta. It's the same. You can try calculators. You try sine, let's say it's more than 5 degrees. 5 degrees, it will be same value as delta. So as we know that, I just give an example from limit and continuity. So we can see sine x over x is almost equals to x over x and equals balance to 1. So now, since the delta x is very small, it approaches 0, we can imply this result. It will become limit delta x approaches 0. So I write back cos x plus delta x over 2 sine delta x over 2 over delta x over 2. Since the delta x approaches 0, hence sine delta x over 2 is almost the same with delta x over 2. So both of these are not 0, hence we can cancel out. It approaches 0 but it's not actually 0, so we can cancel out and we get limit delta x approaches 0 cos x plus delta x over 2. Now, when delta x approaches 0, we can assume this equivalent to 0, so it's equivalent to limit delta x approaches 0 cos x plus 0 and equivalence to, and here we get the cos, here we get cos x. So how we derive sine x, differentiate into cos x by using the first principle of differentiation. Alright, so here is the first thing of the things we must learn. So it's sine x, when we differentiate it become cos x. So I will explain another in this video, that is cos x. When we differentiate it, when y equals to cos x, we get the dy dx equals to negative sine x. Of course, the same theory, you can just memorize it, or you want to learn the derivation, is okay with you. So let fx equals to cos x by using the first principle, and you will realize that in the end we get the f prime x equals to negative sine x. Here x is a negative. Then I want to give some tips on the theory. Anything start with core. When differentiating, it will get a product with negative sign. Means that, like, we differentiate cos x, we get negative sine x. When we differentiate cot x, we get negative cosecant square x. This is something like a rule. When we differentiate something with core, we will get a term at the finalized with a negative sign. Okay, now the third, we will differentiate the tangent x to become dy dx is secant square x. Alright, how we differentiate it? Fx equals to tangent x. You can use the first law or the first principle of differentiation also, but in this case I would like to teach you how to use the quotient rule. So let tangent x, we know tangent is equal to sine x over cos x. Alright, so f prime x, by using the quotient rule, apply quotient rule. Hence we know that here cos square x, here will become cos square x. Here is cos x, and we will copy and we will differentiate the numerator, which is sine x. Differentiate sine x, we know now is equal to cos x, right? Since d dx sine x equals to cos x. Now we know that quotient rule is minus sign, so so we copy back the numerator and differentiate the denominator cos x. When we differentiate the cos x, we get negative sine x. I hope you all still remember. Here is uv uv prime, is vu prime minus uv prime, and here is v square. Alright, so now we will get the answer is cos square x. Here is minus minus, so we get a positive sine square x over cos square x. As we know, sine square x plus cos square x will be equivalent to 1, so it's 1 over cos square x. We know that cos square x, 1 over cos square x will be equivalent to secant square x. You ask me how do I remember secant square x equals to 1 over cos square x? Actually got one formula. You can see the secant. The third letter indicate the first letters of its reciprocal. So I know that secant square x is equivalent to 1 over cos square x, or secant x equals to 1 over cos x. So here we derive the differentiation of tangent x. Alright, so I will talk about number 4. It's cotangent x. Y equals to cotangent x. Now, when we differentiate cotangent x, we will get dy dx equals to negative cosecant x, cosecant square x. As I said, when we differentiate something with co, we will get negative sign in the end. So how are we gonna differentiate it? Let's see. Now y equals to cot x is quite similar with when we differentiate the tangent x. We let cot x equals to cos x over sine x. I hope you all understand this, because here is 1 over tangent x, and 1 over tangent x is 1 over sine x over cos x. When we move the cos x out, so it becomes cos x over sine x. When we divide the x, we use back the quotient rule, and we will get sine square x. Here is sine x. Then we differentiate cos x, we get negative sine x minus quotient rule, and minus cos x times back the cos x here. Alright, so by the process we get negative 1 over sine square x, where sine square x, negative 1 over sine square x. 1 over sine square x we know is reciprocal. This one is the third letter, so we can see what third letter is, C-O-S-E-C, cosecant x. The third letter indicate the first letter of its reciprocal, so we can see here is the relation. Alright, here we using by quotient rule, we get the derivations of the cotangent x. Okay, I hope you all can catch up. Okay, for number 5, we get y equals to secant x. So when we differentiate it, we get dy dx equals to secant x tangent x. If you want to just memorize the whole thing, you can just like secant x. After differentiate, I bring one more tangent x. Yeah, just like that. Yeah. So how we derive it from the differentiations? So here we go. Y equals to secant x. We know that secant x equals to 1 over cos x, and cos x will become here minus 1, right? So we differentiate it by using chain rule. Here we use the chain rule here. Everything we can use first principle, but I just want to show you different method to derive it. So we put the chain rule here, we will move in front, so it becomes negative cos x, we copy back what is inside the brackets, and here power reduced by 1, -1 minus -1, it becomes -2. And now we must multiply back what is inside the bracket. We still remember d dx cos x with equivalence to negative sine x. Don't relate with this negative is outside, alright? So here, so we get negative sine x. So we can cancel out the negative. So we get sine x over cos square x. Now we try to separate out sine x, cos x times cos x. So we will get back sine x and cos x is actually tangent x. And hence 1 over cos x, we must know here got the 1 here. So put the unity here. So 1 over cos x we know is secant x. So we get the answer. So here's how we derive for the secant x. Alright, so here is the last term, I think. The last trigo we learned is cosecant x. So when y equals to cosecant x, when we differentiate it, we will get dy dx equals to negative cosecant x cot tangent x. If you bring one more cot tangent x behind it, if you just want to memorize, and as I said, when you differentiate something with cot, it will get negative at the end. Alright, so how are we going to derive it? So we will apply the chain rule. So you know that y equals to cosecant x is equals to 1 over sine x. Is also equivalent to sine x to the power of -1. So you apply the chain rule. I hope you can try yourself. It's the same way, exactly the same as what I do for the secant x, and you will get, at the end, you will get dy dx equals to negative cosecant x cotangent x. Alright, so here is all the differentiations for the 6 terms, 6 trigonometries in this video. So I hope you can remember the useful tips I just dropped just now. Useful tips. When we differentiate anything, start with cos. Start with cos means that it's called either cosine, either cotangent, or either cosecant. We will end with the negative sign. So I just want to make a summary, quick summary. I better write in the next page. Okay, so summary. We can, if you you can just skip to this part, and if you want to just memorize all the things, and you can skip the derivation by just memorize, of course. Yeah, but if you want to learn maths, learn the beautiful maths, of course I suggest you to learn the derivations. But I know SCPM don't have so much time to play with that. So sine x and differentiate, I hope you also remember, is cos x. The second, cos x is cos, so we get negative sine x. The third one is tangent x. Tangent x, we get secant square x. And number 4, we have cos x. When we differentiate cos x, we start with cos, so we get negative cosecant square x. And number 5, we get secant x. Then we using, after we differentiate, we will get secant x. It will bring one more tangent x. Same go with the last thing is cosecant x. So since we differentiate start with cos, we get negative sign, negative cosecant x copy back, and hence bring a cotangent x. So here is the 6 main, I can say this main differentiation for trigonometry. So thanks for watching. So next part I will be teaching about the logarithms functions. Alright, thanks for watching.